To solve this integral problem, this is what we call a definite integral, because we're integrating from 1 to 2 of x plus 1 over x to the power of 2. So this is a definite integral. So after x integrating this expression, we're going to substitute the value of 1 and 2 into this integral. Okay, so but the first thing you want to do in this case is to expand this integral. So let's expand. X plus 1 over x squared can be written as x plus 1 over x, and then x plus 1 over x. Okay, and then we want to open the bracket, so we multiply x times x gives us x squared, x times 1 over x gives us a 1, then we go to 1 over x times x gives us 1, and then 1 over x times 1 over x gives us 1 over x squared. So this entire thing becomes, I'll group this as x squared, and then 1 over x squared, and then plus 1 plus 1 is 2. So this entire expression becomes this. So our integral can now be rewritten as integral. In place of this, now we put from 1 to 2, we say x squared plus 1 over x squared plus 2. Okay, we can put a dx. We can put a dx also. All right, so let's integrate. So we're going to integrate each of the terms. We integrate the first term. When we integrate the first term, x squared is going to give us x squared plus 1 over 2 plus 1. Because of the power, we add to the power and then we bring it to the bottom. The same thing is going to happen to this. Plus the second term. To integrate the second term, we can write it as x to the power of minus 2. All right, then we add a plus 1, and then we have minus 2 plus 1 at the bottom. To integrate this last term is going to be 2. Since we have 2 here, we can say x to the power of 0, and then plus 1 over 0 plus 1. Remember, we are integrating from 1 to 2. Okay, so this expression becomes, let's break this down. So x to the power of 2 plus 1 gives us x to the power of 3 over 2 plus 1 is 3. At the bottom, we have a plus x to the power of minus 2 plus 1. That gives us x minus 1 over minus 1. Okay, minus 2 plus 1. All right, and then we have a plus 2x. 0 plus 1 gives us x. So this entire expression becomes this. So what we want to do now is to put in the limit, the intervals from 2 to 1. So we're going to evaluate this expression by substituting 2 into this and subtracting it from substituting 1 into this expression. Okay, let's squeeze that in here. So putting 2 into this expression, we have 2 to the power of 3 over 3 plus 2 to the power of minus 1 over minus 1, then plus 2 bracket 2. All right, and then we whatever we get from here, we subtract it from, when you substitute 1 into this, this is 1 to the power of 3 over 3, then plus 1 to the power of minus 1 over minus 1 plus 2 bracket 1. All right, this is what we get. So when you break it, finally you're going to get your final answer. So 2 to the power of 3 becomes 8 over 3. The minus comes, and then we have minus 1 over 2, and then plus 4. Okay, this is what we get from the first integral. Then minus the second integral, this becomes 1 over 3 minus 1 over 1, which is 1, then plus 2. So the task here is to evaluate this fraction, and we are going to get our final answer. So when you simplify this at the end of the day, you're going to get minus 13 over 6. So why not give this a try, verify your answer and compare with what I got. Okay, I simply broke down this entire fraction and then I got this. All right, so this is how you solve an integral of this kind, and you can also apply the same principle to other problems like this. Okay, so thank you for checking out the video, and I'll see you in the next one.